Hi, welcome to this video tutorial of DC motor. So here I am going to explain you how a DC motor works and what is the working principle of it. So first let us look about how internal of the DC motor looks like. So here we have the things labeled over here, like this is the rotating part is called the commutator, and this is the brush, and the commutator has coil over it that are like coiled in a solenoid manner. Then these outer rings are actually stator magnets, and the whole thing is rotating around this shaft. So this is how a simple DC motor looks like. So let us see what is the functioning of a DC motor. Now a DC motor is a type of motor which can be rotated in both the directions depending upon in which direction we are sending the current to, and maximum working voltage depends upon the rating. For example, we can have 12 volt motors, we can have 6 volt motors, and depending upon the stator winding currents and how much it can take. Then the instantaneous torque and speed are dependent on instantaneous power. So actually if we give the maximum voltage, then in the case of maximum load it can give the maximum torque. So torque is dependent upon the load that which it is applied on, and it's variable. Also the speed, if we increase the voltage then we will get increased speed depending upon also the torque conditions and the load conditions. For example, if the load is more, when suddenly if we say the load has increased when the speed was large enough, but due to the increased load now we have to apply excess torque, so the motor actually steps down its speed and increases its torque, and this thing actually happens automatically due to the internal mechanism, and in this way the load is balanced. So now let us see actually what are the pins of a DC motor. It has actually the VCC and the ground, so only a supply pin and the pin completing its circuit, the ground, and the working principle behind it. So it's quite simple actually. It is same as the Fleming's rule. It follows where if we have our right hand thumb pointing towards top, then the coil then the current is in the rotational direction pointed by the other four fingers. For example, sorry, it was in the right hand, it was the left hand. If we point our thumb in the top direction, and our curled fingers actually denote the direction of the current. So if we have this as the this is the path through which the current flows, then the electrical field is actually in this plane, and because of it the magnetic field, which is always perpendicular to the electric field, is in this direction, and the resultant of both actually produces a net force that is given by BIL cos alpha, and this alpha actually varies, and this actually helps the armature to actually balance the inertia and rotate in the direction in which the electrical current is flowing. So in this way the DC motor works. Now here what we have is an arrangement of edge bridge network along with a microcontroller and its supply and various switches, so that we can drive the motor in both the directions. Now actually an edge bridge is a connection, is a network of circuit that allows the motor to be driven in either direction, also giving it enough of the current, as our microcontroller cannot provide enough current to directly drive the DC motor. And also if we connect a DC motor directly to a battery, we can have only one direction through it. So if we want a control over the motor that it should be rotated in both directions, so for that purpose we need an edge bridge, for which we have a circuit over here. Instead of the circuit we can also use simple ICs like L293D, but for demonstration purpose we have this circuit over here. So now the code in this controller is given such that depending upon the PWM it will vary its direction, and the PWM will actually give the power to the motor to rotate. So actually let us see the simulation. So as you can see, the power that is being delivered to the motor is very less, and that is why it is rotating very slowly. Now if I increase the pulse, then the net voltage that is getting delivered is more, and that is why the rotational speed has increased now. So actually it is directly proportional to the amount of voltage it receives, and that is why the speed is directly proportional to the voltage that is applied over it. And also we can see that by our microcontroller we can actually set in which direction the motor should rotate. For example, it is now rotating in the counterclockwise direction. So now by adjusting the voltage, we can now see that it's rotating in the clockwise direction. So actually the phenomena behind this is whenever we have one of the switches on, so that a current is flowing from this to this junction, and we should have this one to be off. Simultaneously this should be off and this should be on, so that there is a direct path between this to here. So we have the motor to be running in the clockwise direction. Similarly, to run it either way, we have these two to be off and these two to be on, so that the current flows from this direction to here and the motor will run in the counterclockwise direction. So in this way a DC motor works, and this was the simulation of the DC motor. Thank you.